Hello, welcome to today's lecture. So we are still on chapter 3. We're going to move on to introducing more topics in probabilities and make it more interesting. There are objectives for today's lecture are actually using combinations and also permutations to actually calculate the probability. Using combination and permutation to calculate probabilities. First of all, a little bit of review. What is permutation? Remember that permutation has to do with having some objects in order or selecting some objects from a collection of objects and then put them in order. So permutation of R objects out of N objects. Follow the nice formula, the permutation R out of N, it was N factorial divided by N minus R factorial. There you go. Remember that when it comes to combinations, you don't care about ordering. Remember the examples, many examples that we did in this class. So combination is just selecting some objects out of a bigger collection of objects. So combination of R objects out of N objects is just selecting those R objects out of N objects or forming subsets with cardinality equals to R or size equals to R. So this is the combination N comma R. It was N factorial divided by N minus R factorial, and we also have to get rid of the orderings R factorial. One example for you. So 3.4, page 1. Here's an example. So in this example, we have a group of 3 people. Group of 3 people. So the question is, what is the probability that at least 2 of them will have the same birthday? What is the probability that at least 2 of them have the same birthday? Okay, what is the probability? You have an event, the event, at least 2 of those people have the same birthday. At least 2 of them have the same birthday. What is this probability? Remember that to find the probability, we need to form a fraction. We have something on the numerator, we have something on the denominator. On your numerator, you get the cardinality of the event, and on the denominator, you have the cardinality of your sample space. Remember also that we talked about complement of an event. If you have an event like E, its complement is the all those values that are not in that event. Think about it for a moment. How we can use the complement of this event to actually calculate the probability. Very good. So remember that if you have an event, for an event like E, so recall for you, so let's write it here. For an event like E, its complement is denoted by E prime, EC, E bar. And remember that when we talked about complement of an event, we had a nice rule. The probability of an event plus the probability of its complement is always equal to 100% or just 1. So what's the relation between the probability of E and probability of its complement? We can write probability of event E equals to 1 minus, you're taking this number, this quantity, and we move it to the other side by subtracting that from both sides, minus the probability of the complement. Very good. So we're going to use the second equation here. So the probability of at least 2 of them have the same birthday is equal to 100% minus the probability of the complement. So what's the complement of at least 2 have the same birthday? What is the complement? So it says that at least 2 of them have the same birthday. So the complement is actually equal to none of them have the same birthday. So the complement, none of them have the same birthday. So what's the meaning of that? None of them have the same birthday. Okay. So it means that the first person you select has a birthday. The second person you're selecting has a different birthday. The third person that you're selecting also has a different birthday. So to calculate this probability, you're actually, so this is 1 minus the probability of this event, which is actually the complement of our given event, is equal to, is the cardinality of this event, so the cardinality or the size, n of none of them have the same birthday, divided by what? Divided by the cardinality of your sample space. How many days do you have? How many birthdays do you have? The cardinality of sample space. So it is equal to 1 minus. How do we select this? So let me erase this part of the board so I can explain it for you. So none of them have the same birthday. So you're selecting the first person. For the first person, how many options do you have? For the second person, how many options do you have? For the third person, how many options do you have? So isn't that familiar? Isn't that the permutation of 3 out of 365? This is actually the permutation of 3 out of 365. Suppose we have 365 days in a year. So the permutation is equal to 365 factorial divided by n minus 3, 365 minus 3, which is 362 factorial. Can we simplify this? Yes, this is equal to 365 times 364 times 363 times 362 factorial divided by 362 factorial. Remember that you have common factors, so you can get rid of common factors. The multiplication is actually give you n of none of them share the same birthday. We could say that, hey, for the first place, I have 365 options. For the second one, I have 364 options. For the last one, I have 363 options. I multiply them based on the fundamental principle of counting. It's multiplication. So on the numerator, you get 365 times 364 times 363 divided by what? Divided by what? Sample space. What would be your sample space? Think about it. What goes on the denominator? Is that a permutation or is that a combination? What is the sample space? 365 times 365 times 365. Okay. Is that a permutation or is that a combination?